It's equal to about 19.8 volts, and 19.8 volts divided by 1k ohm equals 19.8 milliamps. I want to show you a interesting circuit here. We have an RC and we have an RE now. And on the base, we have it biased at some DC voltage here. Problem is how to look at this transistor. We know that we have a 0.7 volt drop because of the base emitter junction. If VCC, let's give this a little bit of values, is 20 volts. VBB is, let's say, 5 volts. What is the voltage right there? V emitter. So if we look at this, if I have 5 volts here, then I actually have to have 4.3 volts here because of the 7.7 volt drop here. So if I have 4.3 volts here, then how do I determine IC, IE, and IB? Well, I'll tell you what, if I have 4.3 volts right here and an RE right there, then I guess I can figure out how much current is in the circuit. That's equal to IE. If this was 1k ohm, then I'd have 4.3 volts divided by 1k ohm is equal to 4.3 milliamps. Oh, okay. If this was 1k ohm also, let's say beta, let's use the same beta we've been using. Beta DC is equal to 100. That means I'd have, for base current, IB plus IC is equal to IE. Well, since we don't know what IC is, then IB, we'd have to figure that out. Okay, so we have a 4.3 milliamps through here, through the emitter resistor. That means we have about 4.3 also on the collector resistor. 1%, since the beta DC is 100, 1% of the current will go this way, and 99% will go this way. How do we find VCE? In order to do this, we need to find the value of the collector voltage. VC is equal to VCC minus ICRC, and that's equal to 20 volts times 1k ohms wind that back up again. Equals 20 volts minus 4.3 milliamps times 1 k ohm, which happens to be 4.3 volts also. So actually this ends up as 4.3 volts. So 20 volts minus 4.3 volts is equal to 15.7 volts. So if VC equals 15.7 volts and VE equals 4.3 volts, then V collector to emitter is equal to 15.7 volts minus 4.3 volts is equal to 11.4 volts VC.